Hello everybody, welcome to Unit 1, Lesson 6. After this lesson, we should be able to do a couple of things. We should be able to construct a parallel line through a given point, and also construct a perpendicular line through a given point. So, before we do that though, a brief reminder about transformations. I hear that you've talked about these before back in 8th grade maybe, in a unit called kaleidoscopes, possibly. Anyway, just wanted to review that briefly since it's coming up soon. It says here that each pair of shapes is congruent. We want to mentally identify a transformation or sequence of transformations that could take one shape onto the other. And type your thoughts below. If you want to do that, pause and try this now on the activity. But I'm just going to give my quick thoughts here. Reminder, there's 3 types of transformations that you should probably remember. There's translations, that's where everything just slides over a certain amount. There's also a reflection, that's where everything flips across to the other side of some given line. And there's a rotation where everything turns some given amount around a point. Real quickly, I would say that the first example looks to me to be a translation, or at least that would be the simplest way to do it. You can translate everything from P to Q. Second one, again, a translation would pull this off pretty nicely if you translated everything from A to C. Then B would also lay on top of D, and so would everything else in the middle. These second two, they appear to be not translations anymore. They must be rotations because the figure is not facing the same way. It's been turned around a little bit. So they're rotations of some sort. Enough said about that for now. These aren't the only right answers, by the way, but it's some stuff to keep in mind. Anyway, back to constructions. We have used straight edge and compass to make a whole bunch of different things, including but not limited to a line perpendicular to a line through a point on the line. Let's build on that today. Let's build on that because that's kind of the way these constructions work. If you know how to do one thing pretty well, you can sometimes apply that to a new scenario. Like here, we know how to make a line perpendicular through a point on the line. Well, what if we want to make a perpendicular line through a point that is off the line? Well, I think we could probably pull that off. I'm just going to jump right in, but if you want to pause and try it yourself, here's your chance. If not, here we go. First, I start and I make a circle. I make a circle centered at C such that it passes through the line in 2 places. I will label those 2 intersection points, A and B. And then I will make a perpendicular bisector of AB in the usual fashion. So circle centered at A with radius AB, circle centered at B with radius AB. Those 2 circles overlap in 2 places, call them, what would they be up to this point? E and D, if I was using things that aren't used yet, okay? And I pass a line through points E and D to make the perpendicular bisector, and lo and behold, it also passes through point C. And so we have a perpendicular line through a point off the line. Interestingly, part of the reason I knew this would work is because we made this circle to start with. That made C equidistant from both A and B. And remember, we said that every point that is equidistant from 2 points is on the perpendicular bisector of the segment. Okay, so what was different about that? Well, I guess compared to what we've done before, the point was not on the line to start with, but since we've made a perpendicular line through a point on the line, I guess it doesn't seem like that much of a stretch to get it through a point off the line. You just had to orient it correctly so that it would pop through the middle of that point. Anyway, so enough said about that. Here is another thing that we're going to try and do. Here is a line and a point C not on the line. We're going to use straight edge and compass to make a line parallel to our starting line that goes through point C. Again, this is where you should pause and try this if you want to. I'm going to pause also and do a few of the steps. Okay, this kind of feels like cheating, but you know what? I'm going to roll with it. So I did all the same stuff that I did back on page 7, where I made a line that's perpendicular passing through C. Now, that's not the question. I want a parallel line to the starting line going through C. But I know that if I have two lines, that are both perpendicular to the same line, then they should be parallel to each other. So if I make a line that is perpendicular to my second line passing through C, it will be parallel to the first line. So again, we kind of already know the steps to make a perpendicular line, hopefully, through a given point. So from C, I'll make a circle, and I will then notice that this circle has 2 points that are on the line. I will construct the perpendicular bisector of segment FD by making circles, center at F, radius FD, center at D, radius FD. See this creepy looking eyeball thing in the middle? How about that? Anyway, is that always there? Anyway, and then I will notice that that circle, again, as usual, has 2 intersection points, or those 2 circles have 2 intersection points, and now I'll pass a line through that, which passes through C as well, and lo and behold, we have 2 lines that are parallel. Fancy. So now you know how to make a line perpendicular through a point not on the given line, and you know how to make a parallel line through a point not on the given line. I will mention that there's more than one way to do this second thing, the making a parallel line, but the method that we talked about, it lets us build on things that we've already done before, so I guess that's cool. Here's some notes if you want to write any of this down about what are parallel lines and perpendicular lines and all that jazz. And this is going to be the last activity. I'm going to pause and do some of it. If you want to pause and try some of it yourself, feel free to do that. Okay, so once again, I did those same steps that I performed on page 7, where I made a perpendicular line that passed through P. I did that because it says here that the original line, now labeled AB, is the perpendicular bisector of segment PS. So there had to be a perpendicular line that went through point P and be perpendicular to this line AB. However, I still don't know where point S is, so what I'm going to do now is I'm going to make one more circle. I'm going to make that circle starting at the intersection of my 2 lines, which I've labeled as point M. I'll construct a circle of radius PM with a center at M, and that circle intersects line PM in 2 places, and so I will mark this far other point over here, and that point must be S because it is the same distance from the midpoint as P. Ta-da! Hopefully that works out for you. Feel free to leave some questions at the end here.